All right, so let's try to make it through this entire packet that you just received now today. This is going to end up being worth 5% of your grade, so not that it's a huge amount, but every little bit helps. Now the thing with that's kind of weird with this review, they already graphed these radicals for us, but we can just kind of pretend it's not there and graph it ourselves. We can still review how to go back and graph. In order to graph these, we still want to identify A, C, H, and K. What's A here? 1. What's C? What's H? -3. And what's K? Now, the thing about radicals is that, remember, on one side they have an endpoint, on the other side it goes on forever, and that endpoint can always be found at -3, sorry, at H and K, which in this case is -3, 0. So weird looking grid too, huh? I guess does it look better on your paper? Yeah, it does. So it's just my screen. Then once you have that, you needed parent points. We can use the table since I didn't use the table before, but some of you guys seem to like it better on this last unit, so we could even use that same table here. It's just that the parent points are going to be different. How many points did we want for a radical? Yeah, ideally 4, and even the shape is similar to that of a log and an exponential, but if you get 3, that's fine. The difference is now you got to see what the parent function is. This is the square root, so whatever I put in for x, I want to take the square root of it, meaning I don't want to put perfect squares. I can't use 0 here. For these, I can't use 0. 0 already counts as your as that endpoint. So what would be my first perfect square after 0? 2 is a perfect square? 1, 4, and 9. Square root of 1 is 1. Square root of 4 is 2. Square root of 9 is 3. Okay. Now there's only one transformation here, which is the h. So it would just be all these x's minus 3. So y stays the same. So the y's are going to stay 1, 2, and 3. These are all minus 3, so negative 2, 1, and 6. So we can just at least verify to make sure, even though this is already graphed for us, we can check and see, hey, -2, 1, it's here. 1, 2, it's here. 6, does it go that far? 1, 2, 3, 4, and then it only goes to 5, huh? Well, 6, 3, if I had enough space, that'd be there too. Okay, what's the domain here? It is not all real numbers. And it's a lot easier to tell the domain because you're actually looking at a picture. So, yeah, how far left does it go? It only goes as far left as -3. This one does touch -3. There's no asymptote. So -3, comma, how far right does it go? Positive infinity with a parentheses. How about the range? Good. 0 with a bracket because it does touch the 0. Like when you have an endpoint and you actually does touch, but takes a bracket, then a parentheses. Okay, here's something we saw with exponentials and logs. Intervals. Intervals tie in directly to the domain. So the only thing is that within that domain, there might be some smaller subintervals where we're changing direction, but that's not the case on square root functions. Square root functions don't change directions. Just leave it there by my computer and grab one of those packets. So throughout this entire domain, it's going to be either doing one or the other. Is this increasing or decreasing? So this is increasing. If this were a roller coaster, it would be going up, and it's doing so throughout the entire domain. How about a max or min? Does this have a maximum value or a minimum value? It does have it does not have a maximum because it goes up forever, but it does have a minimum. What's the lowest value? If you put -3, 0, that's fine. I'll take it, but the more important one, when we're talking about max or min, we're talking about high and low. If intervals have to do with domain, max min has to do with the range. the lowest point here is at y equals 0. But again, if you put negative 3 comma 0 in parentheses, that's fine. Okay, our favorite and behavior. The x, how far left is the x going? Negative 3, and when x goes to negative 3, what's y doing? Going to 0. Victor, what you thinking about? That's, if you make a fist, you'd be in the thinking man pose. There it is. There it is. I like it. Huh? Yeah. Yeah, I'm saving that for the end because that's algebraic. These are all just looking at the graph. And then on the right side, where's the arrow going? Positive infinity, and then same thing for y, positive infinity. If by now you don't understand it in behavior, like I just don't know what I can teach you today to make you understand it. All right, now as Musi requested, let's work on the intercepts. But intercepts should be found algebraically. Even if you could see it on the graph, like here I could tell the x-intercept, obviously. The y would be a little harder, but I can tell that there is a y-intercept though. Let's still do it algebraically. How do we find an x-intercept? By plugging in a 0 for y. So if I do that, it would be 0 equals square root of x plus 3. Yeah, okay, that's gonna be. Alright, how do I get rid of the square root? Square, but if I square 0, that still gives me 0. So x ends up being negative 3. So the x-intercept is at negative 3 comma 0. How do I find a y-intercept? Plug in a 0 for x. Y equals. Kate, you got that? So like to find a y-intercept, you put in the 0 for x. And with radicals, if you can simplify them, simplify them. If not, leave it alone. I would not round this. Please don't force me to make a decision based on your rounding, and if you round incorrectly, there's really no need. 0 comma square root of 3. And if you were to take the square root of 3 and you would get 1 point something, that's why you can see on the graph that this is crossing in between 1 and 2 because it ends up giving you 1 point something. But let's just leave it as square root of 3. Any questions there? Most of you are juniors and you've done performance finals for 3 years in math. I'm sure you know by now these tend to very closely mimic the actual performance final. So if you understand this, you should be fine. For the next one, let's graph another square root function. Let's first, it's already graphed for us, but let's just confirm what's on there. What's A here? What's C? What's H? No, 0. That negative 2 is outside of a square root. That's a K, which is why the endpoint is at 0, negative 2. Dennis, what's the domain? No. Domain means how far left and how far right. So first we go with how far left. You were correct about the bracket part, but how far left are we going? No, you keep on saying negative. No, it's just 0. Just 0. How far right are we going? Positive infinity. Dennis, for the range. Range means how low and how high. Negative 2 with the bracket because it touches, and then positive infinity. Is this increasing or decreasing? Yeah, this one's also increasing, and it's going to do so throughout the entire domain. So just repeat what's on the domain. Does this have a maximum or a minimum value? Kaylin, when does this have a max or a min? Speak clearly. Come on. Zero. Okay. Well, that's not the question I asked you. I asked you if it has a max or a min. It does have a minimum, and if you put 0, -2, that's fine. But really, the minimum value of the function, the minimum output, the minimum value that this function could output is at -2. Shina, end behavior. What's the left side doing? There's no arrow there, but what's the left side doing? It is going as far as 0, and when it's going all the way to 0 on the left, where is it going up and down? No, it's going to -2. For radical functions, one of the end behaviors is just going to be the endpoint. Whatever the endpoint is, you just repeat it. Now, what's the other side doing? This side does have an arrow, even if you can't see it. Yeah, positive infinity, positive infinity. I pointed out to you yesterday that you can see these values also in the domain and range. Moosey's favorite now, x-intercept and y-intercept. The y-intercept should be obvious from looking at the picture, but let's just prove it algebraically anyways. Let's start off with x-intercept. Put a 0 where the y goes, so we get square root of x minus 2, so plus 2 on both sides. 2 equals square root of x. How do you get rid of a square root? Square. 2 times 2 is 4. So x-intercept is 4, 0. Actually, both intercepts here show up on the graph. For the y-intercept, put a 0 where the x is, which basically just cancels out. It gives me -2, but we knew that already. Any questions there? All right, square root equations. What do we want to do? Who remembers the first phase of a square root equation? Say it again. Isolate the radical. Before we can isolate the variable, we have to isolate the radical. The reason why you want to isolate the radical is so that you can remove the radical. How do you get rid of a square root? Square. Now I could already tell this is going to end up giving me an extraneous solution because a square root can't give you a negative, but let's prove it. So we get 9 equals x plus 6, which is what type of an equation is this, Stephanie? Good. And being that it's linear, it only gives me one solution. But before you get too excited and start doing cartwheels, what types of radicals need to be checked for extraneous? Not all of them. So even index. If this was a cube root, you don't have to. You can always check. It's just if you're getting something that's inconsistent, it's not because it's extraneous, it's because you made a mistake. But even indexes can. Did you get a packet? Oh, man. Right away, sir. Randy, where were you on that, man? Your comrade does not have a packet. Oh, these things didn't come out front and back. So when we check for extraneous, 4 would have to be equal to square root of 3 plus 6 plus the 7 on the outside. So 4 would be equal to square root of 9 plus 7. So 4 would have to be equal to 3 plus 7. So 4 would have to be equal to 10, which is not true. Therefore, that's extraneous. So what's my solution? That there is no solution. Or that symbol is called the empty set. It's used usually to demonstrate no solution. If you write no solution, fine, even better. On the next one, the radical has already been isolated, so it's ready to be removed. Kate, how are we going to remove that radical? Yeah, so it's ready to be removed. How are we going to do that? Very good. Square both sides. Just to save space, because I don't have a ton of space. Just please remember that you can't distribute the square. On your paper, if you need to write it as x plus 4 times x plus 4, and then FOIL it out. But just to save space, I'll do x squared plus 8x plus 16. That's what I would end up with, is equal to 4x plus 21. Stephanie, what type of an equation has this become? Yeah, it's quadratic. So Alice, what should I do next? Being that it's quadratic. You want to ask Tabarak? Tabarak, do you know? Anita? Yeah, let's make it equal to 0. Move all the terms to one side. Minus 4x minus 21 minus 4x minus 21. Once you have it equal to 0, what are your two options? What are your two options? Dos opciones. What are they? Quadratic formula, but that seems a little bit of overkill for this one. Or, yeah, the very controversial factoring, which here would be x plus 5 and x minus 1. X equals negative 5 and x is equal to 1. But wait, there's more. Even index radical, what do we got to do? Check for extraneous. These are the solutions to a quadratic equation. They are not necessarily the solution to a square root equation. So I got to go back to the beginning. And check and see if these work. I plug in the negative 5 plus 4. Yeah, that's going to be an issue, because there's no way that square root is going to give me a negative, but let's just prove it. This side is negative 1. This side gives you square root of 1, so negative 1 is not equal to 1. Caca. Not a solution. If the next one works out, great. If not, what happens? Then it'll have no solution. Thank you, Lucy. So we go now with a 1. 4 times 1 plus 21. This is 5. This is square root of 25. 5 equals 5. All the children rejoice, because x equals 1 is our only solution. Okay, number 3. This is kind of a discussion. Discuss, like, meaning that you have to have some type of a narrative, like sentences and stuff. It doesn't have to be like a huge essay, but I think like 2 or 3 sentences should suffice. Discuss why the domain and range of f of x is equal to square root of x are restricted. What do we call this? When you say f of x is equal to square root of x, what is that called? Seriously? That's the parent function. That's a parent function for square roots. Yeah, no, I'm asking, like, what's the name of that function? That is the parent function for square root. And if I were to, and this is not part of the answer, this is just to help you understand why the answer is coming. You don't, if you get this type of question, you don't need to write this. But just to help you, like, see what I'm talking about, what is the domain of that parent function? Very good. Yeah, it'd be 0 to, I can put in from 0 to positive infinity. And what would the range be? 0 to positive infinity. If you go on the Wayback Machine to your notes when I gave them out to you, you would see that, like, if this is the coordinate plane, a square root function looks like that. It's kind of like half of a parabola. It's just without the other half. So now the question is why? Why is it restricted? Why don't I have a domain and range of all real numbers? Very good. Yes, you would. You have to say something along the lines of um, the domain. I'm not gonna write full sentences, but you can take care. Like I'm not huge on grading on grammar and stuff like that. Like it's not. I'm not gonna be too critical. So you dress it up nice and pretty. But the key points would be that uh that if you input, see what numbers are not included in these sets? Negatives, right? Because we got zero and positives taken care of. The only thing that's, what's being restricted are negatives. You can't input a negative, you can't output a negative. And you would say that inputting a negative would cause an error, meaning it wouldn't give you a real number. And so you could say something, therefore there could be no real output. I guess I did have somewhat of a sentence structure there. Inputting a negative would an error? Oh man, would cause. Would cause. Would and cause? I think I liked you better when you were in the thinking man pose. Would, cause an error. Any questions there? All right, let's go here. Expand the following logs. Be sure to explain how you did so. Okay. For the explanations, I just really care that you don't necessarily need to give me a narrative here. Just tell me what properties you used. Because we talked about for expanding and condensing that a lot of times it's easier to do it in one step. Even though there's multiple steps going on, if you do it in one step, that's fine. But you got to tell me what properties were used if you want full credit. Okay, so here we're expanding. Mohammed, I'll let you show off for the ladies first. How could this be fully expanded? Well, okay, there's obviously going to be quotient property because of the division. Is that the only property? Every property is being used here, except for maybe if change of base. You're not going to need change of base, but Musi? Say that again? You don't worry about the format. You worry about knowing everything. If you're asking that question, it's because you want to try to evade having to understand something. So I want to make sure you understand everything. So here, I'll do the first one for you then. Mohammed got stuck. Log base 4 of 3 plus 2 log base 4 of x minus 7 log base 4 of y. What did I mean, if we're going to list the properties, everything was used here. There was power property, there was quotient, and there was product. Everything was used here. I just did it in one step. And what did I tell you about any factor that comes from the numerator? Any factor that comes from the numerator, what happens? No. The other one. Make sure the log is positive. So notice how this log base 4 of 3 was positive. You just don't have to write the positive there. Notice how the 2 log base 4 of x was positive. Whoa, but I don't get it. Where'd that 2 come from? That's power property. If you would have done it one by one, you would have started by saying x squared, but eventually the 2 would come to the front. Do not leave the exponent up there. And then what happens to any factor from the denominator? That log is negative. How did the 7 get to the front? Power property. I don't have that much space, so let me erase this one here. Okay, this one should be a little bit easier because there is no quotient here. What am I going to write first? 3 log A, good. Okay, this is a base 10 log. What am I going to write next? Plus log B. What am I going to write last, Caitlin? When? What am I going to write next? Plus 4 log C. Lamson, what properties did I use? Power, yup. For the 3 and the 4, we use power property. And please write the whole thing out, right? Power property, quotient property, product property, but power property, what else? And just product. There was no quotient here. Stephanie, Felix, let's see if you can do the next one. What am I going to write first? No. Good. 23 comes first. Then log base 2 of m. Okay. No plus. Minus, good. No. Because that 5 is not a power. Minus log base 2 of 5. And then? No, minus is correct, but what's after the minus? 4, because that exponent would have moved to the front. If you want to do it in multiple steps, go for it. I just think you're less likely to make a mistake if you do it in one. Minus 4, because that 4 would have come to the front. The same way the 23 came to the front, the 4 would come to the front, but with a minus. Then log base 2. All the logs have to be base 2 here. Of? No, the 4 belongs to the... This 4 exponent belongs to the n. And then finally the last thing? Yes. Not p. Every little thing has, this needs a log, this needs a log, this needs a log, that needs a log. Everything that's being multiplied. So minus log base 2 of p. What properties were used here? All of them. Everything. Power, quotient. Now I know what's going to happen. If you're going to decide to do these and they're going to throw in this little wrinkle and you're going to blame me for it. Change of base, even though it is a property, it is independent of any condensing or expanding. Like, it can be done either way. Or better yet, simplifying can be done in any single one. So, like, see, here's a log that could potentially have been evaluated. But what's the problem with log base 4 of 3? What type of number would you get if you were to take that log? Irrational. It'd be irrational. So we leave it. Sleepy? Hey. Here's the only other one that I saw that you could potentially try to take. But what happens there? What happens there? Huh? Like I literally just said it, if you're paying attention. It's irrational. But here, crazy thing. Let's say on the actual test, let's say instead of a 5, that this would have been like an 8. Let's just say for argument's sake, meaning this would have been an 8. What's log base 2 of 8? It's 3, so you would be expected to put minus 3. If you wanted the full credit, you'd have to actually evaluate. You need to evaluate any log that can be evaluated. It's just that on these examples here, none of the logs could be evaluated. That makes sense. So we just leave them. Okay, let's do condensing. Notice how, in order to condense, we have to have all of the same base, which we do. We also have to have the same coefficients, which we don't. So maybe for these, you might want to take one extra step. Like you might want to rewrite this as log base 4 of x to the 5th plus log base 4 of y minus log base 4 of z squared. Just to get rid of those coefficients. I just got the 5 and moved it up to an exponent. I got the 2 and moved it up. But now that I have that, I can just write a single log base 4. What's going to go on top? What's going to go on top? X to the 5th. And y, what's going to go on the bottom? Z squared. Nothing else can be done here, so we're done. What properties were used here? Everything. We use product here because of the plus, we use quotient because of the negative, and we use power on the first step. So this one, power, product, property, and quotient. Tabarak, you want to try the next one? Well, do we see anything that can be done with power property? No? Yes? What? Sorry, what can be moved up to a power? The 3 and the 6. So this would be log A minus log of b to the 3rd minus log of c to the 6th. Now that I have all the same coefficients, I can bring them together. This log is a common log. It's just base 10 log. What's going to go on top? Only the a, because that's the only log that has a positive in front. What's going to go on the bottom? Thanks, Tabarak. B to the 3rd, C to the 6th. What property was used here? This was only power and quotient. We didn't have any product here, because there wasn't more than one positive log. In order to use quotient, you only need one log to be negative, because that's what brings the fraction bar. But actually, no, I take it back. I'm sorry. No, I take it back. Down here, there is. Just kidding. There is product. Never mind, because those were both negative. This is all 3. No questions there. Okay, no, you see how it says here to explain your process? That just means that next to each step, write what you did. Just verbalize it. What type of equation is this? This is exponential. Good. What's the good thing about exponential? Who remembers what's the good thing about it? Say it again? You don't need to check for extraneous. Let's isolate the base. Minus 5 minus 5. So 2e to the negative x is equal to negative 2. Divide by 2. E to the negative x is equal to negative 1. How do you get rid of a base on an exponential? Take the log of the same base, which here is going to be ln. So ln of e to the negative x is equal to ln of negative 1. That's going to be a problem. So we get negative x is equal to ln of negative 1. You can still multiply by negative 1 if you want. Which would give you x is equal to negative ln of negative 1. Well, go ahead and put that in the calculator. Put negative ln of negative 1 in the calculator. If it makes it easier, you don't even need to put the first negative in. Just take ln of negative 1. Yeah. Whoa. But Mr. Romero, you just finished telling me that I don't have to check for extraneous. I didn't check for extraneous. It's just there was no solution. It's not because it's extraneous. It's just there is no real number that you can put in for x here to make this true. Any questions there? Okay, now for these last two, we should have we need to check for extraneous. What do we want to do with logarithmic equations? Oh, I'm sorry. Thank you. Yeah. Well, I kind of already did, but here, how would I explain the steps? Subtract 5. Divide 2. Take ln of both. It's just like what I said verbally. Just take ln of both sides. Multiply both sides by -1. And the last thing you did is you just evaluated. No, you can't because it's no solution. This number doesn't exist. This is not real. If it were real, then yes, you could leave it like that. You don't have to round unless it tells you to. But that's not real. Okay. All right, let's go with the next one. What do we got to do first with logarithmic? Huh? Yeah, isolate the log. -4 cancels out. Log base 9 of 3x minus 7 is equal to 2. Now that I've isolated the log, how do I remove the log? Convert to exponential. 3x minus 7 is equal to 9 squared, which is 81. Here's the base. Take that to the power of what's on the other side of the 2. So I get 3x is equal to 88. Do that right? 81, 3x minus 7. Yeah. This is not irrational, but it is a decimal, so I'm just going to leave it like that. With logs, though, what do you need to do? Check for extraneous. To save time, Alishan, do I need to write it? Like if I could tell you here, what was my first step if I were to write it out? What was my first step? Subtract 4. What was my next step? Convert to exponential. So we've been saying it all along. What's the next step after that? Add 7. Good. Just write that right next to it. What's the last step? Divide by 3. And then now with what I'm about to do, what would I say? Check for extraneous. Perfect. Put it back into the original one. Log base 9 of 3 times 88 over 3 minus 7 would have to equal 6. The 3's cancel here. 88 minus 7 is 81. So 4 plus log base 9 of 81 should equal 6. Log base 9 of 81 is 2. You don't have to write down all the steps on the check. Just as long as you say check for extraneous once, that's fine. Because you're just evaluating. And this does check out. Uh-oh, multiple logs. What do? You need to condense, which means here we got to use power property. So we would have log base 4 of x squared minus log base 4 of 6 is equal to log base 4 of 24. Now this is interesting because we have logs on both sides. If there was anything else other than a log, you'd have to put all the logs on the same side. Here you can get away without it. Now, we do need to condense this here. Like what property can I use to bring those two logs together? Quotient. So I would say log base 4 of x squared over 6 is equal to log base 4 of 24. Now, do you see how both sides have log base 4s? Okay, so we can just make what's on the inside equal to each other. You can basically eliminate the log base 4s. If you want for the explanation of that step, just say what you would have said over here, which is convert to exponential. Treat that as just converting to exponential. Even though, actually, well, it's not exponential, but you can If you want, you can just put remove log. That would work also. Yeah, because it is not an exponential. Oh, but I guess neither is the other one. Yeah, you know what? Go for it. You can say convert to exponential. Either one would work. Times 6 x squared is equal to 144. Yay, Alishan is here. Very good. Square root, square root. This is a big one. X is equal to plus or minus 12. Let's quickly verbally, this will be on the video.